Everybody's getting in. I'd like to introduce our next speaker, but he's already been up here speaking this morning. It's PaulCoggin here, who, by the way, is the one who single-handedly, arranged almost everything for this BSides event and did a great job. I'm not sure he deserves a clap for that yet. No, I'm just kidding. Great job, Paul. Paul is a senior principal cybersecurity analyst with Dynetics here. He does a great job especially on network and ICS SCADA devices. He is a EC Council certified instructor. He's a Cisco System certified instructor and a certified SCADA security architect. He has an MBA degree in something like mathematics, so he's good at math for us. That's a really good thing. He has a master's degree in computer information systems and a master's degree in information assurance and security. And because he had a little bit of free time, he decided to go back for a master's in system management. Then Paul's going to talk about networking. Something about networking, as he said earlier, redneck networking.
Okay. So, before I get into this, I also want to call attention that this thing is working today. This BSides has been executed, and it would not be happening as smooth as it is if Tom Gates and Janet Phelps did not help me and shepherd me through this organization and executing this. Just want to let you know that they're the brains behind the operation that made it go smoothly, or it would have been interesting this morning without their help. So let's talk here is about hijacking MPLS networks. And the inspiration behind it is, have you seen in the news about the BGP hijacking that has been happening where IP previous networks, different networks around the world have been hijacked by telco service providers around the world that may not own the IP addresses that they decide to maybe accidentally start advertising. Well, basically what happens, if you go back to some of the most famous incidents that have happened accidentally, back in 08, a telco in Pakistan accidentally started advertising IP addresses that YouTube owned. ChinaNet accidentally advertised Facebook. China Telecom accidentally advertised 50,000 blocks for a few minutes. I'm reading that there's networks in Russia that are accidentally advertising networks. Here recently, there was a service provider in Iceland that started accidentally advertising somebody else's networks. And basically what happens when in the global network, BGP protocol is how your IP address networks are advertised so that there's end-to-end connectivity, and there's an implicit trust relationship by the big tier 1 providers that everyone that ties together into what is the internet backbone, that they're doing their job and they're filtering and controlling who advertises routes into the network, and that everyone owns the IP space that they say they do. But that's not always the case, and accidents can happen. So they say it's an accident. I'm kind of jaded about being in this security business about what's an accident. So here's basically what it looks like from a very, very high level. You have what we call an AS number, an autonomous system number. And if you want to advertise routes directly into the global internet, you have to go to one of the global internet registrars. In the U.S., you would go to ARIN. In Europe, you'd go to ROT. In Africa, you'd go to AFNIC. In South Central America, you'd go to LACNIC. You go to APNIC in Asia Pacific, and you would go and fill out paperwork and get an autonomous system number. And you would also have to be able to justify that you need independent routable IP addresses to the internet. And typically what that would entail is you'd have to get multiple internet connections to the internet. And I'm not talking about a DSL modem and a cable modem. I'm talking about serious network connections to the global internet. And it's typically a large enterprise or a service provider that is going to have these type of connections. And in the U.S., one of the things that I do here at Dynetics, we've been in this business since 99, 2000 of building telco service providers, and we do a great deal of work in this BGP cloud. In the U.S., where we do the majority of our work, the U.S. carriers, they have granular control of what their customers advertise up into the global internet cloud. They have very strict control, real strong configuration management. They have really strict engineering reviews to control, to keep things like happening from like somebody accidentally advertising somebody else's IP address space that they don't own, maybe introducing a loop into the global internet. So in the U.S., we have most of the telcos have very good practices. Where you see most of this hijacking happening is outside of the U.S. Another example, if you're interested in this, here there is an ISP in Canada. Network engineer was going after Bitcoin and started advertising IP addresses of other organizations so he could steal Bitcoin. But what happens? You got this implicit trust relationship, and there's nothing to stop someone that has gone rogue from advertising your IP addresses as their own. And what that enables is for them to do a global level, a macro level man-in-the-middle attack. If you've been through any kind of hacking class, you've been through, you've learned about ARP poison and all the other layer 2 man-in-the-middle attacks, real basic stuff that you can do on a local area network and hijack somebody's traffic. Well, this can happen at a global level doing this BGP hack. And so you could go and redirect someone's IP addresses, their IP traffic to you on a macro layer. Now, you're not going to get it for the whole internet, but you could influence traffic, say, out of Southeast Asia, anyone that's closer to you out of Southeast Asia, you could start advertising their addresses and swing a percentage of traffic over to your network and either drop it, modify it, inject it, and forward it on if you so choose. But what I want to talk to you today about, because there's a lot of information out there on the BGP hijacking, but what I want to talk to you about is what it's not being talked about. Again, we build these networks across the country, do a great deal of consulting in this domain in building BGP and MPLS networks. And the thing that we understand is there's this convergence that's been happening for many years. It started in the early 2000s of, the voice, video, internet, data, digital networks, everything consolidating to one infrastructure. You do it in the enterprise with voice over IP. Everything is being consolidated down. Instead of having 2 or 3 networks, 2 or 3 cable plants, you have one now. Well, the same thing's happening in the telco space where they buy one big router, one BFR, one big freaking router, as big as that door in many cases. And they can take that router or routers and split them out across their network, and they can provide their Metro Ethernet services, wide area network services, internet services, run voice, cell traffic, all across those different networks, and they can break that network up. Just like you virtualize your servers, you can virtualize the routers with MPLS. So you got one router, and the point I want you to get across to you, whoever is doing this BGP hijacking around the world, they also have access to your private wide area network. How many of you guys run MPLS networks for your business? Multi-protocol label switch networks. You got VPNs. Whoever is configuring that also has access to the global internet. They have access to the Metro Ethernet. They have access to everything because it's running over one router. So I want you to get is whoever has access to that, they could accidentally misconfigure those routers to possibly hijack your MPLS traffic, and you'll never see it. On the global internet, there's methods that you can see when somebody starts advertising somebody else's IP address space that doesn't own it because it's in the public. But your private MPLS network is private, and we'll get into this, and I'll show you how. So here's where things fall apart. Our language, our definitions of certain terms have been hijacked, and this is one of them by marketing and sales. MPLS VPN. You go talk to your service provider. You need some private wide area network connections. We used to all go buy dedicated T1s or frame relay, maybe an ATM circuit to get between our different facilities. If say we had branch offices, maybe across the country, around the world, we would go get frame relay or a point-to-point T1. Well, now everybody gets an MPLS VPN because it's more economical, and they call it a VPN, a virtual private network. Where in the term virtual private network do we define encryption? It's not there. But when somebody says VPN, we automatically assume it's encrypted. That's not the case. What I want you to walk away from is out of this diagram here is ATM, frame relay, the old X.25, VLANs. That's all VPNs. It's a virtual private network. It's virtual. You do VLANs, you just carved up a switch and virtualized it into multiple networks. It is not encrypted until you overlay encryption on it after the fact. If you go and buy an MPLS wide area network service, you're not getting encryption unless you go in and add encryption. So here's what's happening with MPLS. If you take any of my classes I teach, I'll harp on the OSI model the whole week until you're sick of hearing me talk about it. But it all comes back to the OSI model. If you're going to attack or defend networks, you've got to go and take it layer by layer, the OSI model, and understand what's happening, and understand the surface of attack and the attack vectors so that you can go and take over somebody's network or defend the network. With MPLS, the label switching, when you hear about MPLS label switching, what's happening is there's a shim that gets injected between layer 2 and layer 3. Say between Ethernet and IP, there's a shim that gets put in between those where you have your, say, traffic engineering labels, your LDP, your MPLS label, and then the label for the customer VPN. And if someone was to go and target your MPLS network or the telco service provider's network, if they can compromise layer 2.5, all of the other layers are theirs. All of the information that is encapsulated in those higher stacks, they're going to own. Now here, for you hardcore network guys that like to live in a PCAP world, I'll give this to you for reference. We're not going to go through this line by line, and I'll give you these slides. They're out on the website. I'll email them to you. But I want you to see what I'm talking about with this shim here. This MPLS label is stuck between the layer 2, the Ethernet frame, and the IP packet in this header here. And you can see we have 3 labels broke out there. Say traffic engineering, MPLS LDP, and the VPN there. And you can look at these offline if you want to do some detailed analysis and better understand that. So here's what the architecture might look like. In the telco core, we have what we call P routers. They're the backbone routers. Think speeds and feeds. Multiple 10 gig, 40 gig, 100 gig. I saw where the other day Alcatel-Lucent has come up with 400 gig optics. In this core backbone, it's all about speeds and feeds. Just pump that data as fast and hard as you can. And then you get to the edge, you got the PE routers, and that's the provider edge routers. And this is where the business is happening. And this is where the hijacking is happening of BGP and of MPLS networks. That the provider edge network, that is where the service provider is going to take a router literally as big as that door, or maybe 2 of them stacked up. They're going to fill up a big rack with, and they're going to aggregate all their customer traffic. It could be private circuits. It could be private wide area network circuits, metro Ethernet. It could be internet. And they're going to virtualize that just like you virtualize your Dell, Cisco, HP server. They're virtualizing that router and carving it up and reselling that router as many times as they can. And they have an engineer that's hand jamming out configs, or they may have some kind of automated provisioning system that's building these configs. And then, whether it's Cisco, Juniper, whatever your Kool-Aid is for router vendors, that's how they aggregate that in. And then the customers, wherever they tie in, that's their customer edge router. But I want you to get it, that PE router, that's where the problems can happen. And whoever has access to those provider edge routers has influence not only over the internet BGP, but over the private MPLS networks. And here's some basic syntax of what an MPLS config would look like. You go in for, say, a specific customer. You need to go and define a VERF for, say, customer A, and give them a route descriptor. And that route target that you see there, that is going to define the policy of what you want to import and export out for MPLS networks. And then I'll show you customer B there and how it gets applied to an interface. If a router engineer was to want to, if you say you had a B2B, you had some kind of collaboration, maybe you have a data center and you're doing some collaboration with some partners and you need to bridge some networks together, maybe there's an acquisition. and you and the company that gets acquired need to tie together your MPLS networks. That could be easily done with a route target import export, where you could import another MPLS VPN into your network and as well export export another network into someone else's network. Or if you're mischievous, if you have the criminal mind, the criminal motive, you could easily go and accidentally import somebody's MPLS VPN into somebody else's, and they will be inside that private network. And that's how easy it is to do. If the telco service provider does not have stringent monitoring and control and logging of who does what, when, and where, with documentation that's automated to know that a change has been authorized, who knows what's happening? It's happening around the world. So here's what it looks like from a virtualization standpoint. A lot of you guys are VMware, Microsoft Hyper-V. You're used to dealing with hypervisors and seeing all your different VMs. Well, here's a router that's been virtualized. Up in the left-hand corner, any of y'all that have dealt with a router, used to seeing a routing table. You maybe go in and do a show IP route and you see all your global routes. If we start applying MPLS to the network, it's say customer A, customer B, then we have to go and do a show IP route and specify that MPLS VPN that we want to look at, and we would only see the routes for that specific customer. And if we wanted to see customer B, we'd have to go specify the show IP route and then for customer B, and that's the only network we would see. And you're going to be like ships in the night. We're in the same water, but we don't see each other. And the only way that these networks can see each other and communicate is with those route target import-export statements. And you can carve this up and add as many customers as you have network resources, processor, memory to be able to support at that telco WAN. And this is another PCAP for you guys that are hardcore network guys and like to live in a PCAP world of how, for most PE devices, how the labels get advertised across the carrier's wide area network in BGP using the extended community strings. That's what I've got laid out here. Like I said, you can analyze this offline. So let's assume that maybe the telco has not been compromised by an insider threat, because nobody wants to hear about the insider threat. There's no insider threat, right? It keeps life simple. All the insiders have been vetted. Snowden, full scope Poly, Manning, he was vetted. But there's no insider threat. So let's go to the outside. Because everybody's on the outside. There's no bad guys on the inside that we got to worry about. We don't need configuration control and monitoring, accountability of who logged in and made changes, but that's not needed. Everybody's a good guy on the inside. That only happens to other people. So how would we go after this network? This is how I think about a network. This is what our customers typically pay me to go do day in and day out, to think both offense and defense. What I look at is we're going to go out and do the recon info gathering. It's not Hollywood hacking. It's all about going and gathering information. If you do a good job on the left side of this screen and go and gather all the information you can about the organization, you go and crawl through their LinkedIn, you go and digest all their press releases where the vendors and certain people are bragging about what got implemented in the network, the technologies that they're rolling out with XYZ vendor for their layer 1, for their fiber, their MPLS, their routers, their network management system, their billing system, their operations provisioning systems. They put all that out there for you. That's wonderful information. You can start reverse engineering, do what I call reverse systems engineering, pulling the big picture together and understanding the trust relationships, the interdependencies, the integration, and get an idea of how that network works and get into the head of the organization and what their skill level is, especially if they just got a new system. If they got a new system, they're worried about trying to get new customers turned up and start making money. Security is going to be down the road, but right now, they got to get that system paying for itself and start making blinky lights and make money. And from an aggressor standpoint, you can take advantage of that. And so we're going to take that information and we're going to roll it over and build ourselves an attack tree based on the information we got. And depending on what's successful, we're going to fork off and come up with a really good strategy that is going to lead to the compromise of that network. But before I move off this attack tree, I'd encourage you to do the type of methodology for both incident handling in your forensics, as well of how you deal with an incident and understand how an aggressor may have came at you, and understand how to go and defend yourself based on attack trees that you develop. So to get back to the telco world, this is an architecture of a single telco, a single service provider. It's called a monolithic architecture. We're just looking at one telco service provider. Just pick one. And so you have, at the top, you got their global internet. They're going to drop down to where they have cross connects, aggregation points at their central offices. A central office is an enterprise's data center. If you're talking to a cable company, they call it a head end. It's a room with a bunch of computer network equipment. Central office, data center, might call it a POP, cable head end. But that's where they're going to be aggregating and doing some cross connects. And then they're going to bring into the MPLS network at those provider edge routers and bring those services and connections in right there in the center of the screen. And then down below is where they're going to bring in and provision different customer networks and services. So what can someone do if they get access to that network? Say they went and did the recon, they developed an attack tree, and they start executing. What are some of the things that they might do? Well, I showed you how you could go in, if you had access to the routers, you could go in and do import-export to bleed someone else's VPN into, you could bleed traffic into a VPN or export traffic to yet another VPN. You can, all the classic layer 2 attacks, you guys have been through OSCP, Offensive Security Certification, maybe CEH or some other basic network training. You're familiar with doing all the ARP, poison, and layer 2 protocol attacks. You might be able to do those type of attacks. You might be able to go and build tunnels like the L2TPv3. Might be able to go and use lawful intercept. Since it's a telco service provider, the telco service providers have to have capabilities in their networks to support lawful intercept, which is basically legally a legal requirement for the Patriot Act and CLIA regulations, where upon summons, upon law enforcement providing a warrant, they have to be able to do an IP-based wiretap, so that if you and I are talking, the traffic that is defined of interest, a perfect copy of it can be sent to the law enforcement when they provide a warrant. If the telco service provider cannot provide that, upon being delivered a warrant, it's like a $10,000 a day fine, I want to say. So they have this capability. What if you're the bad guy and you break into this network? If the feature's there, if you're a hacker, you hack it. You use what was meant for good for your purposes. So you could be, you could define the traffic that is of interest to you and have a perfect copy sent to you. Why not? If you're familiar with doing port mirroring, if you're into packet analysis, you're familiar with doing port mirroring, span port. Well, you could go and do a port mirror over the wide area network with ER span and point to an IP address and mirror traffic out to an IP address somewhere in the world and leak out that traffic. But I want to revisit what I mentioned to you about possibly doing an import-export of someone else's private MPLS network. This has actually happened. I've had someone talk to me, pull me aside at another event somewhere in the U.S. Single network. All of their branch offices were using one telco service provider, and they discovered that coming out of their private network, they discovered that out of their private network provided by the telco service provider, that there was traffic from Russia exiting their internet perimeter. Imagine their surprise. Like I said, you've got to use encryption to protect yourself. So something happened. Either the telco service provider had someone get turned, an insider got compromised, or they got hacked. And because the telco service provider got hacked, that trust relationship enabled someone using Russian IP address space to exit back out their internet backbone. So to go back to how would somebody take over this network, here's another example. how somebody might, an aggressor may go after the network. And I'm talking about take over the whole telco service provider. I worked on a project. How many of you guys have wide area network projects? Got lots of branch offices. You have a lease. You have a service provider that provides you equipment. They provide a lights out wide area network. They provide you pay them so much a month. They provide you with a circuit. They'll provide you with routers. They'll manage it. You don't have to worry about anything. You just worry about your servers. Down here in this bottom right-hand corner, we took over a network for a organization, and the telco service provider, they were transitioning from one provider to another. The original provider, they had maximized the money, the economic value of the equipment that they had at the customer prem spread across the country. And it was going to cost them more money than the equipment was worth to ship the equipment back to the home office and have it destroyed. So they abandoned all their equipment in place. The customer decided he was going to, that's good equipment. You don't want it back, I'll use it. And they reused it with their new carrier. You know what they left in those routers? Username, passwords. Up here in the top center, that circle there, that's where the brains of the operation is. Yeah, all the IP addresses for the devices that are trusted to do network management, provisioning, configuration, all the security operations, all those IP addresses are in there. The network management, SNMP, community strings, access lists, how they think about their protocol configurations. It's very nice and convenient. Think about what that would give someone. All of that good intel about what's happening at the top of that network of how they architect things. All it would be needed is for a bad guy to get a hold of that and then go and do a little LinkedIn, find out who works for the organization, send in a phishing email, get that initial handhold on a couple engineers, and you can go in and surgically strike that network because you know what you're going after. You're not going to go in there and do some cheesy port scanning and NSS scans. You're going to go do a surgical strike. You're going to phish somebody, you're going to piggyback on them, and you're going to start spreading influence. And then what could happen from that type of attack is you could then turn around and take over the whole transport infrastructure. You could take over their optical network, their MPLS network, their BGP network. You could take everything over by simple mistakes like that. Now, here's the original genesis behind this. The idea I had was an international network where you have multiple telcos that are integrated together with peering agreements, just like they do with BGP. And you have a customer, say, in the U.S. that needs a circuit in Southeast Asia, or maybe they need a circuit in Asia, South America, Asia Pacific, Eastern Europe. They're going to give you a single bill. They're going to give you a single quote that I can provide you a service anywhere in the world, and you're going to get a single bill. They're not going to tell you that they have all these peering agreements and they don't own the copper ever around the world. They don't own the fiber around the world. And so there's going to be a trust relationship as you traverse across the world, across that MPLS network, between all these different carriers. And some of these nations, some of these carriers may be under the influence of nations that may not be real friendly to the U.S. Or they maybe say they are, but they're, they play both sides, and or they're influenced by organized crime. Why could they not just as easily as they're hijacking BGP, sniff your traffic, hijack it, inject, modify, do a DOS? Nobody's talking about this. So what I want you to get is if you're not encrypting that traffic, you're inheriting a great deal of risk. So what can you do about it? It's not all bad news. This is real easy to fix. On the BGP side, you need to monitor your network prefixes. There's BGP Mon. They have a service where you pay a subscription and they will monitor your IP prefixes and let you know that your IP networks have gotten hijacked. Robert talked about threat intel earlier. Let me give you an idea about threat intel. Why not only monitor your networks to see if they've been hijacked, but monitor your peers, your suppliers, your competition, and get some intel. Maybe they haven't hijacked your network yet, but if they're hijacking your suppliers, your subs, if they're hijacking your peers, whatever your competition is, maybe you're next on the list. It'll give you some intel that it's coming. on this point too, I would say there's if you don't want to pay the subscription service, you want to just learn about what's happening. There's a site called BG Play. Go check out BG Play out on the web, and they archive 10 days of traffic. You can go back at the past 10 days if you don't want to go and do something like BGP Mon to proactively monitor and have that automated for you. On the MPLS side, you've got to use encryption, and do not let the service provider manage the encryption. I showed you some real quick examples of how the telco could be attacked and taken over. And I'm telling you, I know one that has, well, I know numerous telcos that have been, service providers that have been hacked, but I know one where they've seen the MPLS traffic bleeding into their network. If you want to outsource it to yet a second, third party to do the VPN if you need to outsource, but don't let the telco have everything. You're inheriting a trust relationship. If the telco gets hacked, you can assume that whatever devices are providing your VPN, that's compromised too. And then in your wide area network, you're injecting routes across your network. For your private network, monitor the network. Us router guys are lazy. Everybody wants to beat on the Windows guys and tell them they need to do the AV, they need to do patching, they need to do application whitelisting. Whitelist your network traffic. If it is not explicitly required, filter it and log it. And if something tries to violate that, if OSPF or BGP or EIGRP starts trying to send you a new route that's not expected at one of your sites, you got something that needs to be investigated. Maybe somebody's trying to help you out with the network. I can guarantee you, if your boss hires my company, I'm coming after your network, and there's going to be new interesting routes in your network. And if you ain't looking, I'm going to have a really good time in your network. And also on top of that, use two-factor authentication. If you're not using two-factor authentication, your network is probably toast. I'm not being arrogant or crass here, but I'm just telling you the truth. My opinion is you're either doing two-factor authentication or somebody's probably using your network freely. It's just they're going to be logging in over your VPN. They're going to be logging in through your website. Your passwords are toast. You've got to go use two-factor authentication. If you want to learn more about all this, here's a lot of references. This is where I learned a great deal of what I know. The attack trees, go out and check out Bruce Snyder. He gives a really good paper on attack trees where I learned the concept from many, many years ago. Check out the ERNW site. These guys run the Troopers Conference over in Germany. They're world class. Ivan is one of the top people in the world. If you want to check out Ivan's books and his website, and check him out on Twitter at iOS Hints. The guy's brilliant. FX and the guys at Phenalet, check out their work. And if you have any questions, you can email me, hit me on Twitter, LinkedIn. I'll get you these slides if you like the slides. And any questions? Sure. No, I'm not saying that. That's not what it's about. It's still being in the telco service provider. But you're inheriting a question like you said there. So you've got it in your local footprint. Like I said, that one slide, when you start going across the world, they have security agreements, just like the internet has security agreements across the network, internet connected like that. So they would MPLS as well. So you're inheriting that trust relationship from them in. You've got to run encryption. Do not let the telco control the encryption part. You need to do it or someone else do it on your behalf. I think we may be out of time now, so we'll prepare for the next speaker. If you got any more questions, you can hit me up in a break or email me. Thank you.